Hi student, this video is about analysis of function, polynomial function. So in this video, I will show you how to find x and y intercept. Okay, number 2, critical point. So before we find critical point, we need to find critical values. Okay, critical values actually refer to values of x. And then number 3, interval where fx is increasing or decreasing. Okay, increasing or decreasing mean if you have a graph on x and y axis, and then if we have first and second quadrant here. Okay, on second quadrant this graph is increasing, and on first quadrant this graph is decreasing. And then number 4, extremum point. Extremum point means minimum and maximum point. So minimum point and maximum point. Okay, next, number 5 is concavity. Concavity is maybe concave up or concave down. Okay, concave up is like this. This is concave up and we have minimum point here. And concave down, this is concave down and we have maximum point. Next is inflection point. Okay, what is inflection point? Inflection point is actually is a point when the concavity changes. For example, from concave up to concave down, or from concave down to concave up. And lastly, I will show you how to sketch the graph based on above information, based on information from number 1 to 6. Okay, next we proceed with example. Okay, for example, we have function fx equal to 2x cubed minus 12x squared plus 16x. And then how to find x and y intercept. Okay, for 1 Roman, I want to find x and y intercept. So to find x intercept, just set y equal to 0. So y here actually refer to fx. So set y equal to 0. Just set 2x cubed minus 12x squared plus 16x equal to 0. You get 2x cubed minus 12x squared plus 16x equal to 0. And then you need to factorize left hand side. So we can factor out 2x times x squared minus 6x plus 9 equal to 0. And you can factor out this function. You get 2x times x minus 3 times x minus 3 equal to 0. So for the first term, we have 2x. So 2x equal to 0, so x equal to 0. For the second term, we have x minus 3 equal to 0, so x equal to 3. And third term, we have x minus 3 equal to 0, so x equal to 0. Sorry, x equal to 3. So now our x-intercept, you can conclude that x-intercept intercept equal to 0 and 3. Okay, now we want to find y-intercept. So y-intercept, we just need set x equal to 0. So we have function y on left hand side equal to, you substitute, we have function y equal to 2x cubed minus 12x squared plus 16x. Just set x equal to 0, so y equal to 2 times 0 cubed minus 12 times 0 square plus 18 times 0 equal to 0. So we have y intercept equal to 0. Okay, now we move to critical point. To Roman, how to find critical point. The critical point must be in point x and y, and x here refer to critical values. Critical value. So in order to find critical point, we need to find critical value. Okay, to find critical value, so actually critical values, actually you just need to differentiate fx and then set equal to 0. We have fx equal to 2x cubed minus 12x squared plus 16x, and then differentiate, we get f prime x equal to 6x squared minus 24x plus 18, and then set equal to 0. So 6x squared minus 24x plus 18 equal to 0. And now you need to factor out left hand side. So we can factor out constant 6 times x squared minus 4x plus 3 equal to 0, or 6 times x minus 1 times x minus 3 equal to 0. So for the first constant, we just ignore. So for the first bracket, we have x minus 1, so x minus 1 equal to 0, so x equal to 1. And the second bracket, we have x minus 3 equal to 0 and x equal to 3. So now we have critical values. Values x equal to 1 and 3. So to find critical point, equal to, you just need to substitute x equal to 1 into fx. So we get 1, and then substitute x equal to 1 into fx, we get x, and then we have 3, substitute x equal to 3 into fx equal to 0. This means f1, this is f3. Okay, next I will show you how to find in interval where fx is increasing or decreasing. 3 Roman, find interval where fx is increasing or decreasing, and want to determine the relative extremum of fx. So relative extremum mean minimum and maximum point. Okay, first we need to find interval fx is increasing or decreasing. Okay, to find the interval, we need to draw a table. Before we draw a table, we need to define the interval. To find this interval, is actually based on value of critical point. So based on our previous solution, we have critical values. Based on critical values, so critical values x equal to 1, 3. So to find or to define the interval, we just need to draw a real number line. We have number 1 and 3. So based on this real number line, we have 3 interval here. So the first interval from left, we have negative infinity 1, and second interval from this value 1, 3, and third interval from 3 to positive infinity. So our table for first column is interval, second column is test value, and third column is sign of f prime x. So our f prime x is 6 times x minus 1 times x minus 3. Okay, for the first interval, we have negative infinity 1. Okay, next is test value. Test value is actually the value of x within this interval, negative infinity 1. Not included negative infinity and 1. So we can choose x equal to 0. And then you just need to substitute into f prime x. So we have the first term is constant. Constant is positive. And then if we substitute into this bracket, okay, 0 minus 1 equal to negative sign. You get negative sign. And then into third bracket, or second bracket, third term. So 0 minus 3 equal to negative 3. And then if you multiply this, positive times negative equal to positive sign. Okay, next, second interval, we have 1, 3, and you can choose x equal to 2. Okay, sign of f prime x. For the first term, we have 6, mean positive sign. Second term, 2 minus 1, positive sign. And then third term, x minus 3, 2 minus 3, we get negative. So positive times positive times negative equal to negative sign. And then the last interval, we have 3 positive infinity. And then for test value, you can choose x equal to 4. And then sign of f prime x, okay, we have 6 equal to positive. First bracket, 4 minus 1 equal to positive. Third bracket, 4 minus 3 equal to positive sign. Okay, next we can make a conclusion for increasing and decreasing. Increasing function means the sign of f prime x is positive. So we have 2 positive signs, mean we have 2 interval that is increasing. and then we have one negative signs, mean we have one interval where fx is decreasing. So we can make conclusion here. Fx increasing in the interval. So we have two interval. The first one negative infinity 1 union, and the second one is 3 positive infinity. And then second conclusion, fx decreasing in the interval 1, 3. This is conclusion for increasing and decreasing function. And our second question is we want to determine relative extremum. Relative extremum means we want to find maximum and minimum point. So to find maximum and minimum point is actually based on sign of f prime x. Okay, we can compare first interval and second interval. You need to compare first and second with third. Okay, maximum point sorry, don't have s in. Maximum point occur when the first sign is positive and then second sign is negative. This is maximum point. And then minimum point when the first sign is negative, second sign is positive. And if no extremum, means for the first sign maybe negative, or we have positive. So if we compare our first interval and second interval, okay, for the first and second interval we have critical value that appear on both interval is 1. So the value of x is equal to 1, and then from the sign we can see that the first sign is positive and the second sign is the negative, mean this one is maximum point. So maximum point here, maximum point equal to x is equal to 1. Why we choose x equal to 1? Because based on these two interval, value of x appear on both interval. X equal to 1 appear on both interval. And then how to find the next value? Okay, the next value is actually value of our critical point. Okay, based on our critical point, if critical values is 1, the value of x equal to x. And then we have minimum point. Okay, to find the minimum point, you need to if you compare interval 2 and interval 3, we have critical value 3. And then if you see the sign of f prime x, it start from negative and then positive. So if we start from negative and then positive signs, it means minimum point. So minimum point here equal to 3, 0. Actually 1, 8 and 3, 0 is referred to critical point. Okay, next. Number 4. for Roman. We want to find the interval where fx is concave up or concave down, and then hence determine the inflection point. Okay, to find the concavity is actually based on second derivative. So for the first derivative, we have f prime x equal to 6x squared minus 24x plus 18. So f double prime, second derivative, equal to 12x minus 24. And then you just need to set f double prime x equal to 0. So we get 12x minus 24 equal to 0, 12x equal to 24, and x equal to 2. So x equal to 2, this is actually inflection value. Okay, we call this as inflection value. Okay, to form the interval of concavity is based on this inflection value. So if we draw a real number line, we have value of 2, so we have two interval here. So the first interval start from negative infinity 2, and then second interval start from 2 positive infinity. So we can draw a table. So first column is interval, second column test value. Okay, third column is sign of f double prime. F double prime equal to 12x minus 24, or we can factorize equal to 12 times x minus 2. And lastly is conclusion. Okay. Sorry. Okay, the first interval we have negative infinity 2. So test value we can choose x equal to 0, and then substitute 0 into f double prime. So we have the first term if 12 means positive. Second term 0 minus 2 negative. We have negative sign. Okay, negative signs mean concave down. So you can make conclusion concave down. And then for the second interval, we have from 2 to positive infinity. We can choose x equal to 3, and then substitute into f double prime. We have positive, and then 3 minus 2 positive into equal to positive sign. Okay, positive signs mean concave up. So you need to remember, okay, if f double prime is negative mean concave down, and if f double prime x signs is positive mean concave up. Okay, you can make conclusion based on this table, or you can write down the conclusion. Fx is concave up in the interval to positive infinity, and fx is concave down in the interval negative infinity to Okay, next we want to find inflection point. So we have inflection value equal to x equal to 2. So inflection point we have 2, and then you just need to substitute 2 into fx, not f prime, not f double prime. Just needs to substitute 2 into fx. So you will get y equal to 4. So 4 actually f2. Substitute into fx. So we get inflection point equal to 2, 4. And then lastly 5 Roman. 5 Roman, we want to sketch the graph of fx using above information. Okay, before you sketch, we can list down all the given all the information based on our solution in 1 Roman until 4 Roman. We can list down. The first one, we have x-intercept. We have x equal to 0, 3, and then y-intercept equal to 0. It's easier to you to draw or to sketch the graph if you list down all the given information. And then number 2, we have information about maximum and minimum point. So maximum point equal to 1x, and then minimum point equal to 3, 0. And then the information we have about increasing and decreasing. We have from negative infinity to 1 union 3 to positive infinity means increasing function, and then from 1, 3 is decreasing function. Okay, next is information about concavity. So from negative infinity to 2, our function is concave down, and then from 2 positive infinity, concave up. And lastly, we have inflection point. Equal to 2, 4. So you need to remember inflection points actually is a point when concavity changes, maybe from concave down to concave up, or concave up to concave down. But based on this solution, it's changed from concave down to concave up. Okay, next, can draw this. Okay, if you have x and y axis, okay, y axis, you need to label, make sure to label, and then okay, the first one we have x and y intercept. X intercept 0, 3. Okay, this is 0, P1, 2, 3. Here is 3. And then we have y-intercept equal to 0. Okay, next maximum point. Maximum point 1x. Okay, this one maybe at this 1x. Okay, so we label 1x is maximum point. And then we have minimum point 30 at this 30 mean minimum point. And then we have inflection point 24. Where is 24? Maybe at this 24 mean inflection point. And then okay, to draw this based on information we have, okay, concavity from negative infinity to 2 concave down, and then 2 to positive infinity is concave up, and then increasing function from negative infinity to 1, this graph is increasing. Actually you can draw based on this point. Okay, like this. And then you label this is fx equal to, okay, you can label this fx equal to 2x cubed minus 12x squared plus 16x. Okay, if we see based on increasing and decreasing from negative infinity to 1, this graph is increasing. Okay, increasing, and then from 1 to 3 decreasing, and then from 3 to positive infinity, this graph is increasing. So if we check based on concavity, okay, from negative infinity to 2, okay, 2 here, this graph is concave down. Concave down means we have maximum point. And then from 2 to positive infinity, this graph is concave up, means we have minimum point. So at this point 2, 4, okay, this concavity change from concave down to concave up. Okay, that's all. Thank you.